We like scientific notation because we don't have to write that number each time we do work in it, because, or we can write 6.02 times 10 to the 23 is this. Yep.
What's the first blank? Does anyone know?
A dozen.
How much is a dozen?
I didn't read it all the way.
I'm missing a lot of blanks.
The mole is defined. So here you go, a definition. The mole is defined against a known standard, carbon-12. It is the number of atoms in exactly 12 grams of carbon-12. In exactly 12 grams of carbon-12. So that right there is a definition. You're going to need to know that. The symbol for a mole, we're going to use small n as the symbol for a mole. And the units are MOL. We shorten them by dropping an E. So when you have, when you report a number of moles of something, you must include the unit, which is MOL, mole.
What was that very important definition you said we had? Is that in this? Is that in here?
That's right there. It is the number of atoms in exactly 12 grams of carbon-12. The mole. It is a very important quantity in chemistry. It is a unit that represents the amount of entities or particles of a substance. Chemists deal with extremely small entities like atoms and molecules, so we need a number to make counting them practical. I don't measure out 12 sextillion amount of atoms. I mass out 1 gram of something, right? So there has to be a way to convert. 6.02 times 10 to the 23rd is called Avogadro's number. In honor of Amadeo Avogadro, it is the number of particles in 1 mole of a substance. Avogadro's number has a symbol, and it is large N, subscript capital A. That is Avogadro's number symbol. The units are particles per mole. Avogadro's number is going to be 6.02 times 10 to the 23rd. So it's not going to change. It is a constant. What will change is the particle. The particle depends on what type of a substance you're going to be using. So we've got some examples there in the table. So you've got elements, covalent compounds, and ionic compounds. Give me an example of an element that is diatomic.
Fluorine.
Fluorine. So let's do this one. Diatomic. Fluorine. That's our example. The type of particle, the smallest whole particle is a molecule. The short form for molecule is molic. So the unit, or the short form, is molic. Give me an example of a monoatomic element. Iron. So basically, this just means any other element, right? Other than the 7 diatomics, so iron. The type of particle is an atom, and its short form is atom. So particles per mole, if we say we've got 1 mole of iron atoms, we've got 6.02 times 10 to the 23 atoms per mole. Okay. Molecular compounds or covalent compounds. Give me a covalent compound. Any covalent compound. Make it short. Somebody said something. No? Give me Shruti.
NaCl.
No. That's not covalent.
Covalent.
Carbon dioxide. Covalent compounds. So, the smallest whole particle for covalent compounds is a molecule also.
Would this be a molecular? There's no
Yep.
covalent.
There's no.
It's the same thing. Covalent means the same thing as molecular.
Okay.
Short form is molic. And then ionic compound. Shruti, you want to try this one again?
NaCl.
Sodium chloride. Now the smallest whole particle for an ionic compound is called a formula unit. Or an FU for short. Between the number of particles and moles is this formula. So N is the number of particles. Small n is the number of moles. And Na is Avogadro's number. So when you do a specific question, you will have to change the word particle to the particle that's actually talked about in the question. So if I say there's 2 moles of sodium metal, you would change the particle to atoms. If I say there's 2 moles of water, you would change particle to molecule. So, magic triangles. This is an aid to help you figure out the formula for finding your unknown. So, some of you are capable of rearranging the first equation to solve for your unknown. Some of you find it a little tricky. To use the triangles, you cover the letter that represents what you're trying to find. What's left is the actual formula. So if I want to find small n, I will cover up small n. The position of the other 2 letters tells you the math. It's going to be big N divided by Na. If I want to find the number of particles, I cover up big N. My formula is small n times Na. Okay? So that triangle helps you figure out number. Do you think you will have a question where it says what is Na?
Yes.
No, because it's a constant. It's Avogadro's number. But if you had to, big N divided by small n. So this is a great way to kind of help you if you get stuck. In a couple of days, I'll teach you dimensional analysis, and for some of you, you will never need another formula. Okay, so let's do the example. How many molecules of water are there in 2 moles of water? So first thing you need to do, some of you are going to need a highlighter, some of you are going to be underlining. Anytime they ask you how many, they're looking for big N. They're looking for the number of something if they say how many. Your textbook, if they say what is the amount, they're looking for moles. So amount is moles, how many is big N. So what do we know here? We know that there are 2.0 moles. So we know N is 2.0 MOL. We know the substance is water, so we know Avogadro's number of particles should be molecules. So we know Avogadro's number, 6.02 times 10 to the 23 molecules of H2O per 1 mole. Or you can write per mole. You don't have to write the 1, but we're going to use it later. So that's what we know. We're looking for how many, so we're looking to find big N.
Wait, what's the bottom again?
1 mole, MOL, because that's the unit. Okay, so 2.0 MOL times 6.02 times 10 to the 23rd molecule per 1 mole. I want you to always put in your units. It helps you keep track of whether or not you've done the correct math. Now, you know from math class, if you have something on the top and the bottom, it will cancel. We've got MOL. We've got moles on the top and moles on the bottom. So they cancel the units, and we're left with molecules of water. So in your calculator, you're going to do 2.0 times 6.02 times 10 to the 23rd. Try it. So that could be, what is the amount of CO2? Put in brackets, what is the amount of CO2 in 1.8 times 10 to the 24 molecules? What is the amount? Okay, so we know 1.8 times 10 to the 24 molecules. So that's big N. We know Avogadro's number.
Good morning, Wesley. Here are your morning announcements for Monday, November 13th, 2017. Cafeteria. Drop into the cafeteria today for lunch to enjoy their potato bowl special and their November-themed cookies. Student services. Applications for the 2018-2019 Minister Student Advisory Council are now open for students in grades 7 to 12. The MSA is a group of approximately 60 students who come from publicly funded schools across Ontario. Members share their ideas and advice with the Ministers of Education on a variety of topics about our publicly funded education system. The Council celebrates student diversity and seeks all...
The answer? Okay. It was 1.8, so 2 sig figs in your final answer. How'd it go? Yeah?
Wait, why did you